Hello students, this video is designed to help you review the problem sets from lessons 1 through 3 in Unit 8. It's all about trigonometry, setting up the different ratios, and trying to determine the missing sides and the missing angles. Take a look at the first problem set. This was the problem set from lesson 1. Try to answer these questions and then come back and see if you got them right. This first page was very straightforward. It was just asking for a bunch of different ratios. It says which ratio represents the sine of B or the cosine of A. So we identify the angle. I did that in black here. And then I highlighted both of the sides that are important. So for example, sine has an important side, which is the opposite, and an important side, which is the hypotenuse. If you look back to the beginning of the video, there was that SOHCAHTOA abbreviation that tells you which sides are important for each of the trig ratios. Anyway, this one should have been 8/10, 15/17, 3/5. All we have to do is identify the correct sides and put them in the correct order. The one that was most difficult on this page was the last one, which was a multiple choice question. The multiple choice question asked about which shows a correct trig ratio for angle A. What we did was we identified this angle A. We said, well, this is the opposite, this is the adjacent, and this is the hypotenuse. And then we labeled every single trig ratio. Notice that in this triangle, there is no 5 sides, so 5 is not even a thing. What we did then was try to figure out whether the correct trig ratios were assigned to the correct actual fractions. Adjacent over hypotenuse, that's for cosine, that's no good. Opposite over hypotenuse, that's for sine, that's no good. As I said, 5 is not even a thing. However, cosine is equal to adjacent over hypotenuse. So there you go, choice number 3. All right, take a look at lesson number 2. Pause the video, try it out yourself, and then come back and check your answers. All right, here on the first page of the lesson 2 problem set, we were doing a lot of finding out of missing sides, which makes sense because this was the lesson on missing sides. For the first one, it asked which single function could be used to find AB. Many students thought that this was a typo, but it was not. I know that this angle is 40 and this angle is 90, which means by the triangle sum theorem, this angle is 50 degrees, which means that its opposite is 12 and its adjacent is AB, the very thing we're supposed to be finding. So tangent of 50 is equal to 12 divided by AB, which means I can use tangent of 50 to find AB. I can't use sine or cosine. Why not? Well, this is the hypotenuse. Hypotenuse is in the sine ratio, and it's also in the cosine ratio. But we don't care about the hypotenuse for this problem. We know BC, and we're looking for AB. In other words, we need whichever one of these is the opposite, and whichever one of these is the adjacent. We don't need the hypotenuse at all. In other words, we can't be using sine or cosine. For question 2, I set up the diagram as follows. I labeled the hypotenuse and the opposite, and I set up the two fractions here. We cross-multiplied and eventually got 32 feet. Remember to write a little sentence at the end of one of these story problems, these diagram problems, just identifying the real-world answer. For question number 3, it was very similar. We were looking for the height of a tree, and we were able to use opposite over adjacent, which is going to be our tangent function. For number 4, it was looking for two things. It was looking for x and also y. This y should be color-coded green. Hopefully you'll excuse me for that. Anyway, you saw the sine setup here. Sine of 70 is equal to 10.39 over x. 10.39 over x, that's opposite over hypotenuse. And then for the second part, we used tangent of 70 equals 10.39 over y. That's going to be our opposite over adjacent. Keep in mind, after we found this value of x, we had two sides of a right triangle. We could have used Pythagorean theorem to find a third. My warning to you is this. If you're using a trig function to find the measurement of a side and you round, that means your answer for the next part is going to have a little bit of error in it because you've rounded. You're not using 11.0567 in your calculation. You're using 11, which means you're going to get a number that's slightly farther off than the actual number. So my warning to you is if you can avoid using rounded numbers inside of your calculations, please avoid it. All right, this is bothering me. I'm going to change it to green. Phew. Okay, great. Anyway, question number 5, it was asking for two different measurements. Again, it was looking for the measure of this ladder and the distance between the base of the ladder and the base of the building. So we did the two calculations. Notice I'm able to set these up very quickly. One thing that is very, very important for you to know is how to use the calculator effectively. So I'm going to show you quick steps on the calculator here. The first thing you're going to do in your calculator is press the mode button. Once you press mode, you're looking for whether it's in degree mode because all of these angles are in degree mode. You'll be learning about angles in radian mode in Algebra 2. If your calculator is highlighted with radians, please go over to where it says degrees and press enter. That means that it is now set in degree mode. And then when you're trying to do one of these calculations, for example, if you're trying to do sine of 60, we do the sine button, and then we press 60. The closed parentheses is not super necessary. Once we press enter, we get a long decimal that's similar to, but not exactly the same as, what if we did a square root? Every time you do a trig ratio, my suggestion to you is you round it to 4 decimal places. That's the tenths, hundredths, thousandths, 10,000ths place. 0.8660 is the answer for this one. And in all other cases, you'll see that I'm rounding to 4 decimal places except for this one. It turns out that the cosine of 60 is not an ongoing decimal. It's just 0.5. That's why this is shorter than all the other ones. All right, take a look at page 2 of the problem set from lesson 2. Try these questions and then see if you're right. All right, more finding the missing side here. We use tangent here because tangent is equal to the opposite over the adjacent, but I want you to notice one thing. The person is holding this kite 3 feet above the ground, so once we find this distance, this x distance, it's not all the way to the ground. There's another 3 feet here. So once we find this distance x, which we solve this equation to get x is equal to 113 feet, we have to keep in mind that it stops here. The rest of the way to the ground is these 3 feet here, so then I'm going to say that the kite is not 113 feet above the ground, it's 116 feet. Keep in mind, this red line is the 113 from our calculation, and the entire height h is 116 feet because of this 3 feet here. Another sort of tricky question was question number 7. It gave us 2 different triangles. It gave us this bigger triangle, which I labeled as Z here, and it gave us this slightly smaller triangle, which is Y. It was trying to find the value of X, which should make sense to you, is Z minus Y, so we had to do it in order. We had to do the larger triangle first. We had to do Z divided by 200. That's equal to tan 28, and I used 28 because this was the angle, 28 degrees. And then once I found this value, which is 106.34, I needed to find this value to subtract that from Z. So I found this value using 18 degrees. That was this smaller angle. This 18 degree angle gave us 64.98. So this distance here is 64.98. The total distance is 106.34. So it should make sense to you that we should take these 2 distances and subtract. The lighthouse is 41.4 feet tall because of that subtraction. Question number 8 was a little bit more straightforward. If you remembered the alternate interior angles theorem, it gave us this, which is called the angle of depression. The angle of depression is when you're standing at a point and you're looking downwards. That's the angle that you make with the horizon. That's the angle that you make with a horizontal line. So the angle of depression going down. It turns out that the angle of depression is always going to be equal to the angle of what's called elevation. In other words, if you're standing on the ground and looking upwards, that's the angle of elevation. And it's because of this alternate interior angle theorem, that Z theorem that we learned about all the way back in one of the earlier chapters in geometry. Anyway, once you know that piece of information, this is a piece of cake. Opposite over adjacent means we're going to use tangent, 215 over x, and we solve it out to get 441 feet. Same thing here. Here's our angle of depression, which is always going to be equal to our angle of elevation. You just learned the big secret of trigonometry. Angle of depression and angle of elevation are the same thing. Anyway, this is 38 degrees. And again, we're going to use tangent. We use tangent a lot in these real world problems where we don't really know the distance from the bottom to the top diagonally, but we can figure out one of the 2 orthogonal distances, either the horizontal or the vertical distances. So you should figure out that the building is 62.5 feet high. This is a little bit of foreshadowing because the project for unit number 8 is going to be involving finding the height of a building. All right, lesson 3 problem set. You're almost done. Pause the video, try these questions, and then see if you did it right. All right, before I do all of these for you, I want to go over the first one briefly. This question is different from the other questions because it has a missing angle, not a missing side. You know it's got a missing angle because it's got this symbol, which is the Greek letter theta. Theta is a symbol that we use for a missing angle. It says to find the measure of each missing angle, which means we're still going to try to set up a trig ratio. We have our opposite and our adjacent, which means we're using tangent, but we don't know this measure, so we can't use regular tangent in order to get the answer. We have to use the inverse of tangent to get rid of this tan. So what we're doing is using the inverse of tan, which is called tan -1, also referred to as the arctangent. So what we're going to do in our calculator is we're going to, instead of using the tan button, we're going to do second tan, which gives us this tan -1, the inverse of tan, and then we're going to type in 6 divided by 7. That divided by is the same as the over bar here. That answer should be 40.601, we're going to round each response to the nearest tenth, it says here, so 40.6 is going to be good enough. All right, now that you have that little primer, pause the video again and make sure that you're doing this right. All right, once you understood this fact, the other ones should have been fairly easy. We rounded all of them to the nearest tenth because that's what it asked us to do. And we used cosine twice. We used cosine once here and once here because both of these were adjacent over hypotenuse. For number 5, it gave us a real-world style problem. It talked to us about this ramp. The ramp has a hypotenuse and an opposite, which means we're going to use sine of theta. We use the inverse of sine to find that theta is equal to 22.51, etc., which rounds up to 23 degrees. And remember, we're using a little sentence to summarize the problem. Question number 6 had a couple of different parts to it. The first part was using the good old Pythagorean theorem. We know that this right triangle here has a 16 side and a 12 side, which means that this last side is 20. There's no better way to memorize this or figure out this method than realizing that anytime you have two sides of a right triangle, you can find the third right away. Anyway, that should have been 20 feet. Once you found that, you read the question and it says the combined length of the two cables R and S is 50 feet, which means if this piece is 20, this piece must be 30. Reading is fundamental. Last but not least, I know that this side of the triangle is 30, this side of the triangle is 16, which means I'm able to use my sine function, my sine ratio, to figure out the value of x. I used theta here instead of x, but hey, listen, nobody's perfect. Our answer should have been 32 degrees because 32.2 rounds down to 32, and we have a sentence to summarize. All right, that was the video on the Unit 8 problem sets from lessons 1 through 3. Good luck studying.